Today we're going to talk about something called margin of error. I'm sure if you guys have been watching the news at all right now that you're hearing a lot of margin of error stuff. The definition of margin of error is that it measures the maximum amount by which the sample results are expected to differ from those of the actual population. Margin of error, it measures the maximum amount by which the sample results are expected to differ from those of the actual population, meaning you have what actually happened, or you have an average of something, and then the margin of error tells you how much your results of a different study can differ or be different from that other study, okay, from the average. Okay, so it's used to find the interval where 95% of the data should lie. So 95% of the data is 2 standard deviations. Whenever we talk about margin of error in Algebra 2, it's always 95%. They have never on a readings exam ever changed from 95%. So it's always 2 standard deviations. And then you have the 95% confidence interval. So to find the 95% confidence interval, you would take your average or your sample proportion and you would add and subtract whatever that margin of error is. Okay? The larger that your sample size is, the smaller the margin of error, because again, the more exact your average ends up being. So just really quickly, just want to go over this one more time. Your margin of error, because it's 95%, if you remember the empirical rule, 95% represents 2 standard deviations away from the mean. So if your standard deviation is 5, then the margin of error would be 10. It's doubled. That's all. Okay? However, you're not always given the number of standard deviations. So you need to know the formula. You need to know the formula to find that. So this is your margin of error formula. Okay? I might refer to it as MO. Okay, your margin of error, is 2 times the square root of P. I'll go over what these variables are in a second. P times 1 minus P divided by N. Okay, so if your margin of error is 2 standard deviations, just this piece alone is the formula to find the standard deviation. Okay, so P is the sample proportion. P is the sample proportion, and N, it'll make more sense in a second, and N is the sample size. N is the sample size. Okay, so in this first example, a survey of 465 high school students found that 82% of them have plans upon graduation of high school. Determine the margin of error for this survey, round it to the nearest 10,000th. So this just wants the margin of error, doesn't want the confidence interval. Okay, so all you have to do is plug this into the formula. So in order to do that, you need to know what P is, and you need to know what N is. So N's easier to see. N is the sample size. We're talking about 465 high school students. Out of those 465 students, 82% of them have plans upon graduation. So your sample proportion is 0.82. It's the proportion of students that are doing whatever it is that the question's talking about. In this case, having plans upon graduation. So because 82% of them have plans upon graduation, your proportion is 0.82. That would be 82% out of 100% is 0.82. Determine the margin of error for this survey. So you have your MO equals, you have 2 times the square root of 0.82 times 1 minus 0.82 divided by n is 465. Just type this entire thing right into your calculator how you see it, okay? Use that alpha y equals button. That gives you a nice clean fraction where you can actually see a numerator and a denominator. That way, especially in later examples, you'll see it doesn't get as confusing. So you type that in, you're rounding to the nearest 10,000th, which is 4 decimal places. So your margin of error is 0.0356. Okay, so let's just talk about this for a quick second. Let's just say that, let's pretend like I actually round to the nearest hundredth. So that would be 0.04. 0.04 is 4%. 4%. So your confidence interval would be 82 minus 4 is 78%, and 82 plus 4 is 86%. So what that means is anywhere from 78 to 86% would be considered normal. Okay? Number 2. Find the margin of error round to, if they ask another school. Okay, obviously for this specific example, that's what ended up happening. Okay, but if they said that that's what ended up happening in a lot of schools, anywhere from 78 to 86 would be normal. Okay. Anyway, number 2, find the margin of error, again round to the nearest 10,000th, for estimating the proportion of green M&Ms in a container. If 21 green M&Ms were drawn from the container in a random sample of 100 M&Ms. So again, your N is the sample size. The sample size here is out of how many total. So our container contains 100 M&Ms. P is the proportion. So in this case, what proportion of those 100 M&Ms were green? So that would be, so in this case, it doesn't give you a percentage. So that would be 21 out of the 100, which would be 21%, or if you want to write 0.21. Okay? What I suggest you do with the proportion, because in a second they're going to get messy, see if you can write it as a decimal, but if it's too long, then just keep it as the fraction. I know it looks ugly, but it's fine. So your margin of error, again, we're just finding the margin of error, 2 times the square root of P is 0.21 times 1 minus P divided by N. We're rounding to the nearest 10,000th, which is 4 decimals, 0.0815 is your margin of error. So again, if you have, let's call that 8%. So if you have a container, right, and anywhere from 13 to 29% would be considered normal for the green M&Ms, that is. Number 3. A dentist noticed that many of his patients that have been complaining of gum soreness have been using a particular brand of teeth whitening toothpaste. To determine what proportion of his patients are using, he selects 35 random files and finds that 27 of these patients are using the same toothpaste. So here there's 2 questions. First, what is the margin of error for a 95% confidence interval? So just like what we did before, what's the margin of error? The 95% confidence interval, again, it's just saying 95%, so 2 standard deviations. So that's why we have the 2 out front. And then state the confidence interval. So for this, you would take your proportion and then add and subtract 2 standard deviations, which is your margin of error. One thing at a time, though. So what's the margin of error? To figure out the margin of error, we have to know what P is and what N is. He chose from 35 patient files. So out of the 35, 27 are using the same toothpaste. So your proportion is that 27 out of 35. Now, if you type 27 divided by 35 into the calculator, it ends up giving you that, it gives you a long decimal, and you can't round this. So I would just keep the 27 divided by 35 in your formula. Again, you can make it look exactly like what you're going to write down by using that alpha y equals button. So your margin of error is 2 times the square root of 27 out of 35 times 1 minus 27 over 35 divided by 35. Again, you can make it look exactly like that. We are rounding to the nearest thousandth, which is 3 decimals. So when you type this into your calculator, that gives you 0.142. So that's for the margin of error. So now for the confidence interval. The confidence interval, your final answer is going to look something like this, where it gives you a lower proportion and an upper proportion. That would be considered the 95% of the data. So if they were to run this study again, what would be considered statistically significant or statistically insignificant? Okay, kind of like an outlier type thing. So to figure out the confidence interval, again, your confidence interval is your sample proportion or your mean in other examples. Okay, in this one, you don't have a mean, you have a sample proportion. And you are going to add and subtract the mo. So in the calculator, you will do 27 over 35 plus and minus that 0.142 number. You can use the rounded because they already asked you for it. So you will do 27 out of 35 minus 0.142. Do the minus first because if you flip these around, you're going to have the smaller number on the wrong side. So when you type that in, you get 0.629. On the right side, you do 27 out of 35 plus 0.142, and that gives you 0.913. So what this means is that about 63 to 91% would be considered normal for using that toothpaste. Okay? And then the last one down here. Following a county election, online survey was conducted asking if eligible voters actually voted. So again, this is not asking you for the margin of error. It's asking you for the confidence interval. So again, your final answer is going to look like this for a confidence interval. It's an interval. So in order to do that, though, you have to find the margin of error first. And to find the margin of error, you can use this formula. Or you can multiply the number of standard deviations times 2, but we don't have that. Okay? So your n value, the sample size, is 1,508 because that's how many people that they're talking about. And then your proportion would be the 986 out of that 1,508 because we're talking about the people that did vote. 986 out of the 1,508 said that they voted. So to figure out your margin of error, you would do 2 times the square root. Again, make it look exactly like this in the calculator. 986 out of 1,508, 1 minus 986 out of 1,508 divided by 1,508. You type that into your calculator, and that gives you this whole long decimal, but the question, again, doesn't really ask you for this, so the only question is for the interval, so you can't round until the very end. So you're going to write 0.0245020088. Okay, so now to find the confidence interval, again, the confidence interval is going to be your proportion plus and minus the margin of error. So you're going to do 986 out of 1,508 plus and minus that 0.02450 number. Okay? Again, this is kind of like back when we were doing half-life and compound interest. You can write down 5 decimals if you want, but you have to keep the whole thing in the calculator. So when you do 986 divided by 1,508 minus that number, that gives you 0.629. We're rounding to the nearest thousandth, I believe, which is 3 decimals, yeah. So we have 0.629. And then when you do the same thing, but when you add it instead of subtract it, that gives you 0.678. Okay, so now really quickly, just notice before in number 3, your margin of error was 0.142, but in number 4, your margin of error is 0.024, so it's a lot less. Okay, the reason why it's less is because our sample size, your n value, went from only 35 to now 1,508, which again, we said that the larger the sample size, the smaller the margin of error becomes, because you have more to back up what number it is that you're getting. Okay, let me know if you have any questions. Homework will be up tomorrow. Have a great day.